Hi there, geometry folks. This is the second section of the final exam review called coordinate geometry. You'll notice that I've went ahead and graphed out all of the figures in all of the problems already. I've done that ahead of time just to save a little bit of time as we go forward. This wants us to classify the following figures using given coordinates. So in A, this is a triangle, but what type of a triangle? It could be scalene if none of the sides are the same. It could be isosceles if two of the sides are the same. It could be equilateral if all of the sides are the same. So I just need to find the distance of all three sides. The easiest one to find is the distance from A to B. Since it is along a horizontal, I can just count. It is 1, 2, 3. That is 4 units long. So AB is the easiest one because I can just count. Now in order to find BC, BC is a distance that's along a diagonal. So as I look along a diagonal, I need to think Pythagorean theorem. A squared plus B squared equals C squared. So I'm going to draw in this little triangle over here. And this is 1 unit, and the other leg is 1, 2, is 4 units. So 1 squared is 1, and 4 squared is 16. And if I add 1 plus 16, BC is the square root of 17. Well, the square root of 17, if you type that into your calculator, it is not 4. So AB and BC are not the same length. Well, let's find CA. So from C to A. So again, I'm going to make this right triangle. And this left leg going up is 1, 2, 3 is 4 units. And going right is 1, 2, 3, 4, 5 units. So the square root of 4 squared, which is 16, and 5 squared, which is 25. If I were to add those two things together, 16 plus 25 is 41. So that is the square root of 41. So you'll notice that AB is 4. BC is the square root of 17. And CA is the square root of 41. All three of those sides are different lengths. So this triangle is what we call scalene. That is a scalene triangle. Let's go ahead and take a look at B. It says it's a quadrilateral, meaning it has 4 sides. So I have it drawn out. It looks like it could probably be a parallelogram. I'll have to prove that. But I'll take a look at, if it's 4 sides, our options are parallelogram, rhombus, rectangle, square, kite, trapezoid. So there are a lot of different 4-sided figures that we could go with. But if I'm going to prove something as a quadrilateral, I need to take a look at their slope, and I need to take a look at their distance. So I'm going to look at RS first, and I'm going to look at UT. And the reason why I chose those is those are 2 easy ones to take a look at, because they both have slope. That is a flat line. It has no rise, but it has run. So the slope of both of those lines are 0, which means they're parallel. And then I'll find the distance from R to S. And since it is running completely sideways, I can just count from R to S is 1, 2. That's 3 units. And from U to T, that is 1, 2, 3 units. And I know one of my theorems says that if one pair of opposite sides of a quadrilateral are both parallel and congruent, then this thing is a parallelogram. So it's a parallelogram. Now, I do want to check and see maybe it is a rhombus. So if it's a rhombus, then I need to check ST. I need to see if ST, let me move some of this up. I'm going to check ST's slope, and I'm going to see, first of all, if it's an opposite reciprocal, because if it is, then I have a 90-degree angle. So ST, the slope, it looks like it rises 1, 2, 3, 4. So rise 4, run 1, 2, 3, 4, 5, 6. So 2/3. Well, 2/3 and 0 are not opposite reciprocals, so I don't have to worry about it being 90 degrees. And if I were to find the distance of ST, would be the square root of, again, here's my triangle. This is 6 and this is 4. So 6 squared is 36. 4 squared is 16. When I add those two things together, that is 52. So the square root of 52 is not equal to 3, so this is not a rhombus. This is just a parallelogram. Nothing more. Let's go ahead and jump down and take a look at C. Here's a quadrilateral. So again, I'm going to just take a look at AB. And I'll do slope on this side. And I'll do distance on this side. So from A to B, looks like we go up 2 and right 3. So my rise over run, rise 2, run 3. And then the distance, 2 squared is 4. 3 squared is 9. 4 plus 9 is 13. So its distance is radical 13. Let's check CD. From C to D, looks like it's 2, 1, 2, and 3. So the rise is 2, the run is 3. So those two are parallel. And CD's distance is 3 squared, which is 9, and 2 squared, which is 4. 9 plus 4 is 13, so the square root of 13. So AB is parallel and congruent to CD. So I know that I have a parallelogram. But now I need to check and see if it's more than just a parallelogram. Maybe it's a rhombus, or maybe it's a rectangle, or a square, or maybe it's a rectangle. So let's take a look at BC. So from B to C. So my rise drops 2. So negative 2. My run is 3. So BC. 3 squared is 9, and negative 2 squared is 4. So this is radical 13. And if I do AD as well, down 2, right 3, and you guessed it, it is radical 13. So all 4 sides are the same. So not is this just a parallelogram, this is a rhombus. And then I need to figure out if it is a square, and we can tell it's a square if AB and BC are opposite reciprocals. And as I look at 2/3 and negative 2/3, they are just opposite. They are not reciprocals. In order to be a reciprocal of 2/3, you would need negative 3/2. So it does need to be flipped upside down. So this is not a square. This is merely a rhombus. Right, as we look at D, quadrilateral with coordinates A, B, C, and D. Again, I'm going to do the same thing. I'm going to find my slopes. And I'll find my distances. From A to B, rise 3, run 4, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So AB is the square root of 25, which we should know to be 5. So AB is 5. Okay, I'll go to BC. Rise, looks like it 1, 2, 3 comes down 4. Run 1, 2, 3. So rise over run is negative 4 over 3. You'll notice that is an opposite reciprocal. 3 squared is 9 and negative 4 squared is 16. Add them up is 25, and the square root of 25 is 5. So BC is also 5. Well, at this point, AB is congruent to BC, and I have opposite reciprocals. You can keep checking the rest if you would like, but you're going to find that CD has a rise of 3 and a run of 4 and a distance of 5. And you'll notice that AD has a slope of negative 4/3 and a distance of 5. So we have a figure where all 4 sides are the same and it has a 90-degree angle. So this we call a square. That is the most specific kind of quadrilateral that you can have, is a square. It has the most going for it. And now as I jump down to question number 2, this is the same triangle that we did in the, I think the first part A. It's the same coordinates, and it wants us to find the area. So the area of a triangle is 1/2 of the base times the height. And since this is not a 90-degree triangle, I'm going to actually have to find the height. So I'm going to call the base AB. And the reason I chose that to be the base is because it's the easiest to find the length of. So the area is 1/2 of the base times the height. So the base, AB, if I count, is 1, 2, 3, 4 units long. And now the height is the distance from the base. If I could extend the base to infinity in both directions, it is the distance from that line to the other point at 90 degrees. So if I were to drop straight down from C, 90 degrees, this is the height right here. This is the height. So I can just count from C. That is 1, 2, 3, that is 4 units high. So the area is 1/2 of the base, which is 4, times the height, which is 4. Well, 4 times 4 is 16, and half of 16 is 8. It is an area, so this is units squared. 8 units squared. And I believe that's it for coordinate geometry.